So the angle addition postulate is very similar to the segment addition postulate. It just is with angles instead of segments. So the big idea is part plus part equals whole. Part 1 plus part 2 equals the whole enchilada. Y'all, the struggle is real. Part plus part equals whole. So in this instance, we see that B is in the interior of angle ADC. B is in the interior of angle ADC. And so then we can draw this ray DB, and it separates that whole big angle ADC into two smaller angles. So this is part 1. This is part 2. And then this is the whole enchilada. Part plus part equals whole. So I can say the measure of angle ADB. Remember, I always put my vertex as the middle point. So angle ADB. Angle ADB. That's part 1. The measure of angle ADB. And what that means, the measure means, so M stands for measure. And for an angle, that means that's how many degrees are in the angle. So we can talk about an angle, and then we can talk about the measure of that angle. So when we're setting up an equation like this, part plus part equals whole, it has to do with like how many degrees are in, like, does the angle measure? So we have to put that little m. And this is going to be really important later on when we do proofs. So start getting in the habit, whenever you're adding angles together, or like setting them equal or something like that, whenever there's an equal sign or you're adding angles, you have to use the measure of the angle. This is super duper important. So we have the measure of angle ADB plus, oops, I meant to use black, plus the second part, this second angle, part 2, is this angle BDC. So plus the measure of angle BDC, that's the second part, equals the whole enchilada. The whole enchilada, which is angle ADC, so equals the measure of angle ADC. Part plus part equals whole. Those two smaller angles added together are equal to the whole enchilada. So for example, if I told you this angle was 20 degrees and that the angle of that, the measure of that angle is 20 degrees, and then the measure of this angle was 30 degrees, how would you find the measure of the whole enchilada, ADC? You'd add them together to get the measure of that whole big angle to be 50 degrees. So just part plus part equals whole. It's just going to get turned up a notch. Okay, so here's our first example. D is in the interior of angle ABC. So I'm going to draw angle ABC. Here's A, here's B, here's C, and I knew to put B as my vertex since, oops, made that way too big. B is my vertex since B is my middle letter. So B is my vertex because B was my middle letter. So the measure of angle ABC is 120 degrees. And then it tells me that D is somewhere in the interior of this angle. So remember, here's the interior of the angle. So I'm just going to put D there. It can be wherever. So now I can draw this ray BD, and now I've separated angle ABC into two smaller angles. So it tells me that angle ABC, which is the whole enchilada, this whole angle is 120 degrees. And then it told me that angle DBC, this smaller angle, is 85 degrees. So if part plus part equals whole, if we know the whole thing is 120 degrees, how am I going to figure out this smaller part is? Well, I can just subtract it. I'm going to do the whole thing minus 85. And that's going to give me 35 degrees. So the measure of angle ABD equals 35 degrees. And remember, if you're ever talking about degrees or it being equal, you always have to put the M, the measure of that angle. It's not the angle is equal to 35 degrees, it's the measure of the angle that's equal to 35 degrees.